Hello everyone, my name is Omar and I'm going to present my work about developing interaction-aware validation oracles for multi-fault program repair. First, let me give you a brief background about the automated program repair technology. This technology aims to generate automatically patches for defects in the programs. So the main goal is to reduce the overall manual debugging and to validate these patches using a specific technique, mainly based on test-based oracles. However, in the past decades, most of the efforts in the APR literature was focusing on single fault program repair, where we assume we have a single isolated or independent fault. In this work, we consider a more realistic but a bit more complex repair setting or scenario where we assume we have a multi-fault program and the faults um, can interact with each other in a different subtle way or unexpected ways. Um, um, Traditionally, for single fault APR, validators use test suites to validate the patches, and they assume complete functional correctness after deploying the patch. However, this assumption is not valid because we deal with multi-fault program and we generate partial patches and then we compose them to get a full or composite patch. So the question that we study in this work is how to validate partial patches in multi-fault context. There are several challenges in this context. First, partial patches may not necessarily transform the program into a fully correct program because we may patch a particular fault and there are other remaining unaddressed fault in the program. The second is that traditional test-based oracle might not be sufficient or actually can be misleading sometimes if we do not take into account or we are not aware of the other unaddressed fault in the program when validating partial patches. Second challenge is that the fault in multi-fault program can interact in different ways. They may mask each other, they may get combined to produce a new failure or new failing or behavior, and they may cascading. We may have cascading behavior where one fault amplifies the impact or effect of the other faults. So to deal with this challenge, we need interaction-aware oracles. In this work, to handle the problem validating partial patches in multi-fault programs, we describe uh, an oracle system that consists of three oracles. The first one is the traditional output-based oracle, which is mainly to check the functional correctness, and a halting oracle, which is very useful when we validated patches developed to address the crash and the hang behaviors in the program. And the assertion-based oracle, which is mainly derived from bug reports. And we analyze the erroneous behavior of the fault in order to synthesize assertions related to these faults, and then we use these assertions as oracles or partial oracles to verify or validate sub-patches. However, to effectively analyze and validate patches for multi-fault program, we need to infer what we call interaction relation I. And the goal is to understand the interaction relationship between the set of faults F in the program and classify these binary relationship among the faults into masking, synergy, cascading, or independent faults, because independent fault can be handled in a different way than interacting faults. So they can be repaired separately, while an interacting fault need to be handled in a coordinated manner in order to avoid rejecting valid patches. We consider a partial patch valid if it fixes a particular fault FLI. It eliminates the erroneous behavior associated with that fault. It doesn't break earlier fixes, and it doesn't hinder the ability of the repair system to detect and repair the other remaining unaddressed fault in the program. As a brief summary of the workflow that we use in this work, we assume we have a program B together with a test suite T. Then we use a combination of program analysis technique like static, dynamic, and an AI to infer the set of fault F in the multi-fault program under repair, the interaction relation I, and the partial order to specify the feasible repair sequence or order that we should follow to fix the set of fault F in the program. Then we try to synthesize sub-oracles for each individual fault. We follow an iterative APR procedure to fix these individual faults. Then we compose them and validate. In case that we miss some fault or the inference of the relationship I was not complete or sound, we have a loop, a feedback loop, and we refine the process until we infer the right or the correct interaction relation I, and we generate a complete or a composite batch that fixes all fault correctly. As a simple example, we have here a sensor processing program, and this program contains three faults. The first fault actually masks the effects or the impact of the other two remaining fault. And these interacting faults, if you try to use traditional single fault APR with traditional Oracle based on test suite, you will miss the faults F2 and F3, and in some cases you may reject valid patches or sub patches for fault F1. So it's very important to infer these faults, understand the relationship or the interaction among them, and then generate a sub oracle to verify them. So in conclusion, this work handle the Oracle problem for a multi-fault program and introduce what we call interaction-aware validation Oracle. It defines the fault interaction relation I, and it discusses how to synthesize oracles for sub-patches. And in future work, we aim to uh, extend our framework to deal with a large scale program because we currently focus on small size program. So we expect to have some integration issues between the multi-fault program oracles, I mean, and the single fault APR system, particularly about the scalability issues. Thank you. This concludes my presentation.